So you're thinking about taking the AWS Associate exam.
Okay.
But you want to actually enjoy the process. Smart move.
Yeah.
We're all about ditching that cram and forget method.
Oh, right.
And making this a learning experience that sticks.
I like that.
Now you've got a set of practice questions, which is awesome.
Yeah.
It's the perfect way to get a feel for what to expect.
Absolutely.
But instead of just racing to the right answer, we're going to really dig into the why.
Gotcha.
The concepts behind the answers.
Makes sense.
To help us unravel all of this and see the big AWS picture.
Okay.
We've got our expert with us.
Hey, everybody.
They're all about understanding how things actually work.
That's what I love.
And why we pick certain solutions over others.
So important.
So to kick things off,
Yeah.
how should someone approach these practice questions? If they want to not only learn, but maybe even have some fun along the way.
I think the key is to treat each question as a puzzle.
Okay.
Don't get fixated on just the right answer. Instead, try to figure out what problem it's posing. Think about the different services you could use and really weigh the pros and cons of each choice.
So it's about understanding the strategy behind the solution.
Exactly. That's what the exam is really testing.
So let's jump right in.
Let's do it.
The first question throws you into the role of a solutions architect.
Okay.
Your mission.
Yeah.
Design a super fast serverless website with top-notch security.
Now we're talking.
What AWS services would you grab for this?
Well, you need speed, serverless, and security.
Yeah.
That points us to a few key services right away.
Okay.
First, for storing the website content, Amazon S3 is a natural fit.
S3, the reliable workhorse.
It's simple, scalable, and doesn't break the bank.
Gotta love that.
Now, to deliver that content globally at lightning speed, we're talking Amazon CloudFront.
So that's our content delivery network.
Right. It caches your content all over the world.
Keeping things snappy for users everywhere.
Exactly. Less lag, happier visitors.
And what about security?
CloudFront's got us covered there, too.
Okay.
It provides encryption in transit.
Keeping that data safe on its journey.
Precisely.
I'm starting to see how these services fit together.
Like puzzle pieces.
Now for question 2, we dive into IAM policies.
Permissions.
We've got an IAM group with 2 policies attached.
Right.
One's super permissive.
Lets you do a bunch of things.
The other one's stricter.
Right.
Specifically denying any actions related to deleting things from the directory service.
Interesting.
So what happens when these policies clash?
This is where the principle of explicit deny overrides allow kicks in.
Okay, break that down for us.
Think of it like this. You have a rule letting people into a room, but then you slap a big do not enter sign on one door.
Oh, you hit it.
That specific denial trumps the general permission.
So in this case, even if the first policy says go wild, second policy's like,
nope, not the directory service.
You can't touch that.
Exactly.
That's a pretty crucial concept.
It is. AWS security is all about layers.
Making sure the important things are locked down.
Precisely.
Now let's say a new engineer joins the team.
Okay.
And they get added to this IAM group with these 2 policies. What can they actually do?
They can do everything the permissive policy allows, except for anything blocked by the second policy.
So they can spit up instances, configure services.
Yep.
But deleting anything from the directory service.
That's off limits.
This really shows how important permissions are.
They are. You have to understand how security works in AWS.
Okay, moving on to question 3.
All right.
We've got a team struggling to keep their IAM in order.
Oh, this is a common one.
New people keep attaching policies directly to users.
Bad practice.
How can they get everyone following the rules?
This is where AWS config rules come in.
I've heard of those, but...
They're like automated watchdogs.
Okay.
Constantly monitoring your environment.
For anything suspicious?
Or like for specific configurations.
Right.
So you can set up a rule that flags direct policy attachment.
Like an alarm bell.
Exactly. So every time someone tries to bypass the process...
The manager gets a heads up.
And can fix it quickly.
Well, that's a pretty slick safety net.
It is. AWS config rules are super helpful.
All right. Question 4 takes us on a hybrid cloud adventure.
Ooh, interesting.
A company wants to make their application faster and more reliable.
Okay.
But parts of it are in the cloud and parts are on their own servers.
A classic hybrid scenario.
What's the winning combo for this?
They need a strategy for both global reach and efficient load balancing.
So it's about making sure things run smoothly no matter where the users are.
Exactly. So they should deploy AWS Global Accelerator.
Global Accelerator, that rings a bell.
It optimizes network paths.
So like creating express lanes to their application.
Exactly. Lower latency, faster response times.
Happy users all around.
And then within each region, they should set up network load balancers.
For both their cloud and on-premises servers.
Yep. That way traffic is distributed intelligently.
Ensuring performance and resilience.
No matter where the servers live.
It's like having a traffic cop directing everything for optimal flow.
That's a great way to put it.
Question 5 brings us to an e-commerce company struggling with product manuals.
Keeping things up to date.
They need to update the manuals across multiple instances, but without messy code changes.
Okay.
What's the elegant solution here?
S3 to the rescue again.
Okay, I'm sensing a pattern here.
Instead of storing manuals on each instance, put them in an S3 bucket.
Centralized storage.
Then redirect downloads to that S3 location.
Nice and simple.
S3's got durability, availability, and versioning.
So manuals are always up to date and accessible.
Plus, no more syncing headaches.
Makes perfect sense.
S3 is often the answer for storage needs.
Okay, question 6 takes us to a startup.
Okay.
Classic 3-tier web application.
The foundation.
They're expecting low traffic at first,
All right.
but they need to be ready for potential spikes.
That's the tricky part.
What's the most cost-effective architecture for them?
This is a perfect case for serverless.
Okay, tell me more.
For the front end, they can use S3 again.
Makes sense for static content.
Super cost effective.
Love it.
Then for the application layer, API gateway and Lambda functions.
So API gateway handles incoming requests.
And routes them to the right Lambda function.
Which does the heavy lifting.
Exactly. And you only pay for what you use.
And they for unpredictable traffic.
And for storing user data, DynamoDB is a great choice.
DynamoDB, another familiar face.
Low latency, scalable, and plays nice with Lambda.
Sounds like a serverless dream team.
It really is a flexible and cost-effective approach.
Okay, question 7 has a company on a quest for insights.
Insights are gold.
They need to collect, process, and store usage data.
Lots of data.
And then analyze it with SQL queries.
SQL, the classics.
Right. What would you recommend?
For this, Amazon RDS for MySQL in a multi-AZ configuration is a solid bet.
RDS, that's our managed database service, right?
Yep. Right. It takes care of all the database headaches.
Provisioning, backups, high availability, the whole shebang.
And multi-AZ protects against data loss.
So even if one availability zone goes down,
the data's safe and sound.
And MySQL gives them that familiar SQL power.
For all those insightful queries,
RDS really simplifies things.
Makes setting up a robust database a breeze.
Now, question 8 throws a licensing curveball.
Okay, let's hear it.
We've got an application with specific software licensing based on the number of sockets and cores used.
Gotta love those licensing quirks.
So what's the most budget-friendly EC2 pricing option here?
In this case, dedicated reserved instances are the clear winner.
Reserved instances, those offer some nice discounts, right?
Big time, especially for predictable workloads.
And dedicated means they get those instances all to themselves.
Right, so they meet the licensing requirements.
Without sharing resources.
Like having your own private pool of servers.
Question 9 presents a storage space dilemma.
Okay, storage is always a hot topic.
An application's running out of room.
Classic.
They need to bump up the storage capacity of their database, but absolutely no downtime for users.
No pressure.
How can they pull this off?
RDS has got some tricks up its sleeve.
Okay, lay it on me.
They can simply switch their RDS instance storage type to provisioned IOPS.
Now, I vaguely remember that one.
It lets you scale storage and performance independently.
So you can boost storage without sacrificing performance.
Exactly. And no downtime for users.
A smooth upgrade indeed.
RDS is all about flexibility.
Okay, in question 10, a company wants to share data from their S3 bucket.
Data sharing, always a fun challenge.
But they want to do it without incurring data transfer costs.
I see. Keeping those costs in check.
So what's the strategy here?
Make that S3 bucket a requester pays bucket.
Requester pays. I like the sound of that.
It shifts the cost responsibility to whoever's accessing the data.
Like setting up a self-service data buffet.
Exactly. They take what they want and pay for their own plate.
Very clever.
It's a simple way to share data while keeping costs predictable.
Now, question 11 throws us into a high-security environment.
Okay, I'm intrigued.
We've got EC2 instances locked down in a private subnet.
No internet access.
But they still need to connect to Systems Manager.
For management and updates.
How do we make that happen without compromising security?
The answer lies in interface VPC endpoints for Systems Manager.
VPC endpoints, those create private connections, right?
Precisely.
Yeah.
So the instances can connect securely.
Without ever going out to the public internet.
It's like a private tunnel just for Systems Manager traffic.
So they get the benefits of management without the security risks.
Exactly. It's a win-win.
All right, for question 12, a media company wants to enhance its recommendation engine.
Okay, I'm listening.
They want to decouple things. So their data analysts can focus on SQL queries.
All right.
They also need no data loss and continuous change detection.
Sounds like a robust data pipeline is in order.
What's the winning combination here?
Well, we'll need a few services working together.
Okay.
First, Amazon Kinesis data streams.
For capturing the clickstream data.
Like a high-speed conveyor belt.
Getting that data flowing.
Then Kinesis Data Analytics steps in.
To process and query the data.
Using SQL so the analysts are happy.
And enabling those real-time recommendations.
And finally, to make sure nothing gets lost.
Okay.
Kinesis Data Firehose comes into play.
To store the processed data.
It delivers everything to S3.
So it's like a data processing factory.
Each service plays a specific role.
Turning raw data into valuable insights.
Exactly. A well-oiled data machine.
Now, question 13 focuses on performance.
Performance is king.
We've got a web app struggling with database queries.
Resource-intensive ones, I bet.
How can they boost performance without major code changes?
A couple of key strategies can help.
Okay, let's hear them.
First, create a read replica of their database.
A read replica, what does that do?
It's like a clone dedicated to handling read requests.
So it takes the load off the main database.
Exactly. Frees it up for write operations. And second, they should consider migrating to RDS.
We've talked about RDS before. Why is it better here?
It offers better performance, scalability, and manageability.
Compared to running a database on an EC2 instance?
It's like giving your database a performance boost.
And simplifying management at the same time.
Exactly.
Question 14 presents a similar performance challenge.
All right, another performance puzzle.
This time, it's an e-commerce company.
Okay.
Their business analysts are hammering the database with read-only queries.
The data-hungry analysts.
Again, they want a solution without rewriting the entire application.
Minimal disruption is key.
What's the least painful way to address this?
You know what's coming.
Hit me with it. Read replicas for the win.
Okay, you've convinced me.
Create a replica.
And send the analyst queries there.
Takes the pressure off the main database.
While still giving the analysts what they need.
It's a classic win-win.
Those read replicas are like performance ninjas.
Silently handling those read requests. Question 15 takes a serious turn towards data encryption.
Security is always a top priority.
This company, migrating to the cloud, has strict requirements.
Okay.
Encryption at rest is a must.
That's standard practice these days.
And they want complete control over their encryption keys.
So they don't want to rely on AWS managed keys?
Precisely. What service can handle this level of security?
When you need that level of control, AWS Cloud HSM is the answer.
Cloud HSM, I'm not as familiar with that one.
It provides dedicated hardware security modules.
Okay.
These are physical devices that you manage.
So they're separate from AWS's infrastructure.
Right. You have full control.
But it still works seamlessly with AWS storage services.
It does. It's powerful and practical.
It's like having your own private Fort Knox for your encryption keys.
A very secure vault.
Question 16 is all about resilience and data consistency.
Okay, two critical aspects.
A company wants to ensure their application stays up.
Even if there's a failure.
And they need their storage to follow the ACID principles.
For strong data consistency.
So how do they achieve both?
Multi-AZ architecture with shared storage is the way to go.
Multi-AZ, that's deploying across multiple availability zones, right?
Exactly. So if one AZ goes down,
the application keeps running in another AZ.
Seamlessly.
And for the shared storage?
Amazon EFS is a great choice.
EFS, that's our elastic file system.
It provides strong consistency across all instances.
Regardless of which AZ they're in.
So your data's always in sync.
A recipe for a robust and reliable application.
Absolutely.
Now, for question 17, we've got a storage capacity crunch.
Storage is always a fun puzzle.
This application uses both block storage and NFS storage.
Okay.
They need local caching.
For performance.
But without a complete system overhaul.
Minimizing disruption.
What's the winning move?
This calls for a hybrid approach.
Okay, I'm intrigued.
For block storage, they should deploy AWS Storage Gateway Volume Gateway.
Storage gateway, that sounds familiar.
It integrates with their existing apps.
But brings the benefits of cloud storage.
Scalability, durability, the whole package.
And for NFS storage.
Amazon EFS volumes mounted to their servers.
So they get the performance of local caching?
And the scalability of EFS.
Best of both worlds.
Hybrid solutions can be very effective.
All right, question 18 has a company selling large data sets.
Data sets for AI, perhaps?
They want to reduce data transfer costs.
That's always a good goal.
Especially for customers far away.
Distance can be expensive.
But they don't want to sacrifice performance.
The classic trade-off.
What's the optimal strategy?
Enable S3 transfer acceleration on their bucket.
S3 transfer acceleration, I haven't heard of that.
It optimizes data transfer paths.
So those data sets zoom to their destination.
Especially for users far from the bucket's region.
And it works with their existing S3 signed URLs.
Yep. No need to change their access control.
A simple but effective solution.
Sometimes the simplest solutions are the best.
Question 19 brings us to the world of healthcare.
Sensitive data territory.
They need to store patient records securely and immutably.
Immutably, meaning they can't be changed.
Exactly, and for a long time.
Okay, so long-term storage with extra security.
What's the best way to handle this?
We need the power of S3 with some extra features.
Okay, I'm listening.
Start by moving the data to S3 using AWS Data Sync.
Data sync, that's for migrating data, right?
Exactly. Then enable S3 object lock for immutability.
So those records are locked down.
No deleting or modifying.
And for auditing and compliance.
Enable S3 object logging and CloudTrail with data events.
A complete audit trail.
Every action on those objects is logged.
Like a digital vault with tamper-proof seals?
And a meticulous record-keeping system.
Now, question 20 is about shared storage.
Shared storage, always an interesting challenge.
We've got a web app running across multiple availability zones.
Okay.
They need frequent content updates
Right.
and strong data consistency.
Gotcha.
What's the recommended approach?
There are actually two good options here.
Okay, let's hear them.
They could use AWS Storage Gateway Volume Gateway in ISCSI mode.
Storage gateway again. Versatile service.
It provides block storage that can be mounted to instances.
Offering high performance and strong consistency.
Or they could go with Amazon EFS.
EFS, our trusty shared file system.
It also provides strong consistency across multiple AZs.
So it's about choosing the right flavor of shared storage.
Based on their specific needs.
Question 21 brings us back to legacy applications.
The challenges of modernization.
A company wants to move their on-premises NFS storage to AWS.
Okay.
To reduce costs and shrink their data center.
Cloud migration, a common goal these days.
But they want to do it without major app changes.
Minimal disruption is always preferred.
What's the most straightforward solution?
AWS Storage Gateway, File Gateway is perfect for this.
File Gateway, I'm starting to see its versatility.
It integrates on-premises apps with cloud storage.
So they can move their NFS shares to S3.
Without touching their applications.
Enjoying the benefits of cloud storage.
Scalability, cost savings, the whole 9 yards.
File Gateway is like a bridge to the cloud.
Connecting those legacy systems.
Right. In question 22, a company is building a platform for machine learning models.
Machine learning, that's a hot field.
These models need to load large data sets from S3.
Okay.
But they don't need persistent disk access.
So ephemeral storage is enough?
They're looking for a cost-effective solution.
Of course.
That's also highly available and low latency.
A trifecta.
What would you recommend?
This is a perfect use case for Lambda functions.
Serverless to the rescue.
They can deploy each model as a Lambda function.
Behind API gateway.
Using path-based routing to direct requests.
So each model has its own endpoint.
Exactly. And they only pay for the compute time used.
Perfect for those variable workloads.
Plus, it's highly scalable and available.
So they can handle those bursts of requests.
Lambda functions are like little processing powerhouses.
Question 23 throws us into the world of IoT.
The Internet of Things. Data everywhere.
A company is collecting tons of data from car sensors.
Okay.
They need a storage solution that's cost-effective for both frequently accessed data,
hot data,
and long-term archival data.
Cold data.
What's the strategy?
S3 intelligent tiering is the perfect match.
Intelligent tiering, that sounds interesting.
It automatically moves data between different storage tiers.
Based on usage patterns.
So frequently accessed data stays in a cheaper tier.
And less frequently accessed data gets archived.
To a lower cost tier like Glacier Deep Archive.
It's like having a data storage concierge.
Making sure everything is in the right place.
Now, question 24 is all about data durability.
Durability, the cornerstone of data protection.
This company is using Redshift for their data warehouse.
Redshift, our powerful data warehousing service.
They want to protect their data even if a component fails.
Okay, so extra layers of protection.
What's the best way to achieve this?
Cross-region snapshots are the answer.
Snapshots, those are like backups, right?
They are, but cross-region means they're stored in another AWS region.
So even if a whole region goes down,
the data is safe and sound.
It's the ultimate insurance policy.
For your valuable data.
Question 25 focuses on ECS and scaling.
ECS, our container orchestration service.
A company's launching an app using Fargate.
Fargate, the serverless option for ECS.
They want to scale based on CPU and memory usage.
To handle traffic spikes.
While optimizing costs when things are quiet.
The holy grail of scalability.
That's the recommended approach.
AWS application auto-scaling is the key here.
Application auto-scaling, I'm not as familiar with that one.
It lets you define target tracking policies.
Okay.
So you can scale based on metrics like CPU usage.
So the app scales up when things get busy.
And scales down when things are calm.
Striking that balance between performance and cost.
Exactly, like a self-adjusting system.
Question 26. Has another company drowning in user data?
Data everywhere.
They need cost-effective storage for reporting and compliance.
Long-term storage.
But they don't need to access all of it frequently.
The classic archival challenge.
What's the best strategy?
A tiered storage approach with S3 lifecycle policies.
S3 lifecycle policies, those are powerful.
They are. So you store data in S3 standard initially.
For those frequent access needs.
Then transition it to S3 standard IA after a while.
When access becomes less frequent.
And finally move it to Glacier for long-term archival.
Where it's cheapest.
Like a data management flowchart.
Each stage optimized for cost and accessibility.
Exactly.
Now, in question 27, a company's modernizing their app.
Modernization is always a good thing.
They're moving from a monolith to microservices.
A popular architectural shift.
They're using ECS for this.
Makes sense for microservices.
But how should those microservices communicate?
The communication challenge.
What's the best way to handle that?
DynamoDB streams is a great option.
DynamoDB streams, we haven't talked about those yet.
It captures a stream of changes to a DynamoDB table.
Okay.
So services can react to those changes.
Without needing to know about each other.
It's a decoupled and scalable approach.
Question 28 is about optimizing batch job processing.
Batch jobs, gotta love those.
A company wants to run 3 applications in parallel.
Okay.
To reduce processing time.
Makes sense. Divide and conquer.
What's the most efficient way to do this?
SQS FIFO queues are perfect for this.
SQS, that's our message queuing service.
And FIFO means first in, first out.
So jobs are processed in order.
But all 3 apps can work simultaneously.
Significantly reducing the overall processing time.
It's like an assembly line for batch jobs.
Back to security with question 29.
Security always top of mind.
We've got an app in a private subnet.
No internet access.
But it needs to access a DynamoDB table.
Okay.
How do we do this securely?
A VPC endpoint for DynamoDB is the solution.
VPC endpoints, again, those private connections.
They keep all the traffic within the AWS network.
No public internet exposure.
It's like a dedicated tunnel to DynamoDB.
Safe and secure.
Question 30 presents a migration challenge.
Migrations are always fun.
That's one way to put it.
They're moving their Linux web servers to AWS.
Okay.
These servers rely on a shared file store.
For content, I'm guessing.
And they want a smooth migration.
Minimal disruption is the goal.
What's the best way to handle the shared storage?
Amazon EFS is the ideal solution.
EFS, our trusty shared file system.
It can be accessed from multiple instances.
And it supports NFS, which is common in Linux.
So the transition is seamless.
Perfect fit.
It's like bringing their familiar file sharing to the cloud.
Question 31 is about optimizing DynamoDB costs.
DynamoDB are NoSQL workhorse.
But costs can add up.
Especially with unpredictable traffic.
This company wants to optimize their spending.
Smart move.
What's the best approach?
Given the unpredictable traffic,
Yeah.
On-demand capacity mode for DynamoDB is the way to go.
On-demand capacity. I'm liking the sound of that.
You only pay for what you actually use.
No need to provision capacity in advance.
Perfect for those fluctuating workloads.
Okay, question 32 brings us back to healthcare.
Sensitive data again.
They need to store patient records securely.
For a long time.
And meet specific retrieval time requirements.
So they need access, but not necessarily instant access.
Right. What's the best solution?
A combined approach using S3 and Glacier is ideal.
Okay, a 2-pronged strategy.
Use S3 for initial storage with cross-region replication.
For durability and redundancy.
Then transition the data to Glacier after a while.
When it becomes less frequently accessed.
Glacier's cheaper for long-term storage.
But you can still retrieve data when you need it.
It's all about finding the right balance.
Question 33 is about predictable traffic patterns.
When you have some insight into usage.
This web app has peaks during business hours.
And low traffic at night and on weekends.
So how can they design their DynamoDB solution?
To handle these fluctuations efficiently.
Without overspending.
DynamoDB auto-scaling is the answer.
Auto-scaling, I'm sensing a theme here.
It automatically adjusts capacity based on workload.
So it scales up during peak hours.
And scales down when things are quiet.
A self-adjusting database engine.
Question 34 takes us to a disaster response team.
Okay, this sounds interesting.
They're working in a challenging environment.
Unreliable network connectivity.
That's tough.
They need to process and store images from drones.
Important data.
But sending it to the cloud immediately isn't always possible.
So they need offline processing.
What's the solution?
AWS Snowball Edge is perfect for this.
Snowball Edge, that's a new one for me.
It's a portable device for local processing and storage.
So they can capture and process the drone imagery on site.
And then transfer it to S3 later.
It's like a mini data center in a box.
Question 35 is about bridging on-premises and cloud data.
Hybrid scenarios always bring unique challenges.
A company wants to analyze data in both environments.
So their data science team can work seamlessly.
That's the dream.
What's the best way to bridge this gap?
AWS Storage Gateway, File Gateway, steps up to the plate again.
File Gateway is proving to be quite the multitasker.
They can copy their on-premises files to EBS volumes?
EBS, those are our block storage volumes.
And then attach those volumes to EC2 instances in the cloud.
So the data is accessible in both environments.
A seamless data bridge.
Now, question 36 is about optimizing message processing.
Message queues can be tricky.
This company's struggling to meet its SLA. Expert.
Welcome back to our deep dive into those AWS Associate Exam practice questions.
It's amazing how each question reveals another layer of the AWS universe. You start to see how all these services connect and work together to solve real-world problems.
Exactly. And as you go through more practice questions, you start to recognize patterns and develop a deeper understanding of the core concepts.
Okay, so picking up where we left off. Question 46, as a company needing a scalable solution to convert large PDF files to JPEGs. They want to store both the original and converted files, and naturally, they're looking for a cost-effective approach. What's the best way to tackle this?
This is where we can leverage the power of DynamoDB streams and Lambda functions. They can start by storing their PDF files in DynamoDB. Now, the magic happens with DynamoDB streams. This feature captures a stream of changes made to the DynamoDB table. So whenever a new PDF is added to the table, DynamoDB streams triggers a Lambda function.
Okay.
This function then performs the conversion, transforming the PDF into a JPEG image and stores both files back in DynamoDB.
It sounds like we're building a miniature document processing pipeline, all without managing any servers.
Okay.
That's pretty cool.
Exactly. The serverless nature of Lambda functions makes this solution incredibly efficient and cost-effective. They only pay for the compute time used during the conversion process.
Question 47 shifts our focus to high availability and low latency for a global application. A company wants to expand its reach to a new region to serve a growing user base. They're specifically looking at the U.S. West Oregon region. What's the best approach to achieving low latency and high availability in this multi-region setup?
To provide a seamless experience for users in both regions, they need a combination of regional deployments and global traffic management.
Okay.
They should start by provisioning EC2 instances and an application load balancer in the new U.S. West Oregon region, mirroring their existing setup in their current region.
Gotcha.
Then, to optimize network paths and route user traffic to the closest available resources, they should deploy AWS Global Accelerator.
Global Accelerator. Right.
Global Accelerator works by providing static IP addresses that act as a single entry point for their application. It then intelligently routes traffic to the optimal endpoint based on factors like network health, geographic location, and endpoint health.
So Global Accelerator acts as a traffic conductor, ensuring users are always directed to the best performing and closest resources, no matter where they are in the world.
Precisely. It enhances both performance and availability by intelligently distributing traffic across multiple regions.
Okay, on to our final question, number 48. A company needs to create an allow list of IP addresses for all their application load balancers across multiple regions. They're seeking a highly available solution that minimizes the number of IPs they have to manage. What would you recommend?
Once again, AWS Global Accelerator is the hero of the hour. By launching Global Accelerator and creating endpoints for each region where they have load balancers, they can consolidate those IPs.
So it acts as a central point.
Exactly. They simply register all their application load balancers to the corresponding endpoints in Global Accelerator. This not only simplifies IP management, but also improves performance and availability by routing traffic through the Global Accelerator network.
So Global Accelerator acts like a central hub for their load balancers, providing a single entry point with a limited set of IP addresses. That's a pretty elegant solution.
It really highlights the versatility of Global Accelerator. It's not just about performance. It can also simplify network management and security configurations.
And with that, we've reached the end of part 2 of our AWS Associate Exam Deep Dive. We've covered a lot of ground, from serverless architectures and storage solutions to security best practices and global application deployments.
Remember, the goal is not just to memorize answers, but to understand the why behind those answers. As you practice more and delve deeper into these concepts, you'll start to see the bigger picture of how AWS services work together to solve real-world problems.
We'll be back soon with part 3 of this deep dive, where we'll tackle the remaining questions and continue our exploration of the vast and ever-evolving AWS cloud. Stay tuned.
All right, welcome back to our AWS Deep Dive.
Ready for the final stretch of those exam questions?
Let's do it. I think you're going to ace this exam.
Okay, question 65. Has a company needing a durable and scalable storage solution?
Okay, storage is always a key consideration.
They need to handle all sorts of things.
Media files, backups, application data.
The whole shebang.
The classic object storage use case.
Oh, what AWS service comes to mind?
This is where Amazon S3 comes in.
S3, our good friend.
It's designed to be highly scalable, durable, and cost-effective.
And it can handle just about anything.
Objects of any size, from tiny files to massive data sets.
And what about controlling how data is stored?
S3's got you covered there, too.
Okay, tell me more.
Features like versioning, lifecycle policies, and different storage classes.
So you can optimize costs and accessibility.
Based on your specific needs.
S3 really is the backbone of AWS storage.
It's hard to imagine AWS without S3.
Now, question 66 takes us to the world of serverless.
Serverless, the future of computing.
A company needs to run code in response to events.
Things like data changes, file uploads, or scheduled tasks.
But they want to deal with servers.
The beauty of serverless.
So what's the perfect service for this?
AWS Lambda is the answer.
Lambda functions, those little snippets of code.
They run without any servers for you to manage.
You just upload the code and Lambda does the rest.
Exactly. It handles scaling and the underlying infrastructure.
And it's triggered by events from various services.
Like S3, DynamoDB, or API Gateway.
So it's event-driven and cost-effective.
You only pay when the code is actually running.
Lambda functions are like those on-demand tools.
Ready to go when you need them.
Question 67 is about real-time data analysis.
Real-time insights, that's powerful stuff.
A company wants to analyze streaming data as it arrives.
So no delays, they need answers now.
What's the right tool for this job?
Amazon Kinesis Data Analytics is the perfect fit.
Kinesis, that's our family of data streaming services.
Data Analytics lets you query and analyze data in real time.
Using SQL or other streaming frameworks.
It's like having a continuous data analysis engine.
Churning through those data streams.
Extracting valuable insights as they happen.
So you can detect trends and anomalies on the fly.
Making data-driven decisions in real time.
That's impressive.
Question 68 takes us to infrastructure as code.
Infrastructure as code, that's a game changer.
It's all about defining and managing your infrastructure.
Using code instead of manual clicks.
This company wants consistency and reproducibility.
Across different environments.
The foundation of good infrastructure management.
So what's the recommended service for this?
While CloudFormation has been the traditional choice.
I've heard of CloudFormation. It uses templates, right?
Yes, but there's a newer option, the AWS Cloud Development Kit.
CDK, is that the one that uses familiar programming languages?
Exactly. You can use TypeScript, Python, Java, and more.
So it's more developer-friendly.
And CDK converts your code into CloudFormation templates.
So you still get the power of CloudFormation under the hood.
It's a great example of how AWS is constantly evolving.
Now, question 69 focuses on relational databases.
Relational databases, the tried and true workhorses.
The company needs a robust and scalable database service.
For handling those mission-critical transactions.
What's a good choice in the AWS world?
Amazon RDS is the go-to service for this.
RDS, we've talked about that before.
It supports a wide range of database engines.
So you can pick the best one for your needs.
And it handles all the database administration for you.
Provisioning, backups, high availability, the works.
Leaving you free to focus on your application.
It's like having a dedicated DBA on staff.
Question 70 is all about automation.
Automation, the key to efficiency.
This company wants to automate their infrastructure management.
Tasks like patching servers, installing software, running commands.
The things that keep sysadmins busy.
What AWS service can handle this?
AWS Systems Manager is the perfect tool for this.
Systems Manager, another powerful service.
It lets you automate operational tasks across your AWS resources.
Yeah, so you can execute commands remotely.
Automate software installations, manage patches, and orchestrate workflows.
It's like having a centralized control panel for your infrastructure.
Automation is essential in the cloud.
Now, question 71 takes a security and compliance turn.
Security and compliance, can't forget about those.
A company needs to store sensitive data securely.
Things like credit card numbers or personal information.
And they need to meet strict compliance requirements.
This calls for the big guns.
What's the most robust solution AWS offers?
For this level of sensitivity, it's AWS Cloud HSM.
Cloud HSM, I'm not as familiar with that one.
It provides dedicated hardware security modules.
Okay.
These are physical devices that protect your cryptographic keys.
So they're physically separate from AWS's infrastructure.
And they meet the highest security and compliance standards.
Like FIPS 142 Level 3.
Essential for handling sensitive data.
Like payment card information and healthcare records.
It's like having a bank-grade vault for your data.
And finally, question 72 is about cost management.
Cost management, the eternal challenge.
A company wants to get a handle on their AWS spending.
And find ways to optimize costs.
What's the best tool for this?
AWS Cost Explorer is an invaluable resource.
Cost Explorer, I've heard good things about that.
It gives you a complete view of your spending patterns.
So you can see where your money is going.
You can analyze historical data, forecast future costs,
and identify areas for optimization.
It even provides cost-saving recommendations.
Like right-sizing instances or leveraging reserved instances.
It's like having a financial advisor for your AWS account.
And with that, we've reached the end of our AWS Associate Exam Deep Dive.
We covered a lot of ground, from basic services to advanced concepts.
I feel much more confident about the exam now.
Remember, continuous learning is key in the cloud.
The AWS platform is constantly evolving.
But by understanding the core concepts and how services work together,
you can tackle any challenge that comes your way.
Thanks for joining us on this deep dive.
We hope you found it helpful and maybe even a little bit fun.
Happy clouding, everyone!